Yo, 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 yo. How's everybody doing? It's Mr. G. We're going to talk about dilations. So, multiple key terms, but a dilation is basically when we enlarge something or reduce the size of it. So, we're making something larger or making something smaller. We do that around the center of dilation, and we also do it using a scale factor. Because the scale factor is how we make sure that everything remains proportional. All right. So, what we have here is we have two triangles. Let me make this all a little bigger for you guys. Is we have look at this one on the top right. We have two triangles. We have my pre-image, and I know this one's the pre-image because it doesn't have the apostrophes. And then I have the new image, which has the apostrophe. So I went from smaller to larger, which means that we made it, this was an enlargement. So we can write that down, but we don't have to. Okay, so that's an enlargement. Now, what we want to do is we want to figure out what was the scale factor. Whoa, spazoid. That was weird. What was the scale factor to go from here to here? Now, there's a couple ways to do this. We're going to look at the one way that is surefire, true, will work every single time. Now, what we can do is we can look at the side lengths of the triangle. So if I look at this side right here, AC, this side is 2. Okay. If I look at the side length for the new AC, 1, 2, 3, 4. This side length is 4. I know actually I'm just counting. I'm counting from how far away is A to C? Well, it's all the way 1, 2. This one's 1, 2, 3, 4. Let's go over to CB. This one is 1, 2, 3, 4, 5, 6 long. Well, this one's 1, 2, 3 long. And then we can't find this side length right here, but we don't need to. So if I went from 2 to 4 and 3 to 6, what they did is we took the triangle and we multiplied it by 2. So you can always take, and I'm going to write this down for you, take the new side length. Sorry about my poor handwriting today. I'm on the slate. No headphones, can't be at the board. And I can divide it by the old. And then this thing's spazzing out. And I can divide that by the old side length. So our new side length was 4. Old side length with 2. So my scale factor was 2. Maybe write scale factor on top of this. I'm going to put SF, but scale factor. Okay? That is all. So this one will work every single time, no matter what the center of dilation was, the point of dilation that we created it. That's why this way works every single time. Try it on this one, see how you do. So this one is a reduction because I am going from the larger one to the smaller one. So this is a reduction. So let's figure out the side lengths, and then I'm going to show you another way to do it because this other way will work when it's the center is when the center of dilation is the origin. So I'll just show it to you so you can see. So 1, 2, 3, 4. Sorry for the squiggles. 1, 2. And then 1, 2, 3, 4, 5, 6. Yeah, I see the spaz. 1, 2, 3. So 6 and 3. So again, we're looking at the same ratios here. So, but remember, we set it up as new over old. So because it's new over old, my new side length over here for DG is 2. My old one for DG is 4. So that simplifies to 1/2. So this one has a scale factor of 1/2. So the scale factors, when it's less than 1, when it's a fraction like this that's less than 1, that's when it's going to be a reduction. If it's going to be a fraction that is larger than 1, then it's still going to be an enlargement. So whenever your value is less than 1, it's going to be a reduction. When it's larger than 1, it's going to be an enlargement. Now, another way I could have done it, I could have just looked at the points for this one. Just look at this point right here. Here at G, my point is at 2, 3. And here at G as well, my point is at 4, 6. I can also set it up where I have my new point over my old point, and that would work as well. It's like my new x over my old x. 2 over 4. 3 over 6. And that would work with any of these points. Okay? Now, if you have to graph the image and perform the dilation yourself, or find the new points with the scale factor as the origin as its center, with the origin as its center, what we're going to do is you're going to take each point and multiply it by whatever the scale factor is. So, what I mean by that is here I have my pre-image A, B, C. The points for A are 1, 1. The points for B are 3, 1. And the points for C are 1, 3. Well, my scale factor is 3. So the algebraic representation for scale factor, the way we're going to write down these rules, is we're just multiplying the new point by our scale factor. I'm using A to represent my scale factor. So I'm just taking the point and I'm multiplying it by whatever my scale factor is. So for my new A, I'm taking these values and I'm just multiplying them by my scale factor. So my scale factor is 3. So I'm taking this whole point and I'm multiplying both values by 3. So my new A is 1 times 3 is 3. 3, 3. My new B is 9, 3. And my new C is 3, 9. Yikes. And then I can graph that. 3, 3, 9, 3, and then 3, 9. And I'm not even going to try to draw a straight line. So what I'm going to do is I'm going to cheat. Just do one of these. Bam. And I still can't do it straight. That's okay. So there we go. By scale factor 3, we blew it up 3 times the size. All right. Now, scale factor is 1/3. Try this one. Write down the new points for A, B, and C, please. So, the original A was, let's see here, we're at 3, 3. Our original B was at 9, 3. It looks like, oh, it's the same triangle. How did we do that? We messed that one up. And then our new C is then at, our original C is at 3, 9. So, but still going over with what we need to do, if we're using a scale factor of 1/3, what I need to do is I need to multiply all of these values by 1/3. When you multiply by 1/3, you're really just dividing by 3. So even though we already know this because the points are right in front of us, we'll write it down anyways. So when I divide everything by 3, those are my new points. So it's really as simple as just multiplying your scale factor by the, multiplying your points by the scale factor to enlarge and to reduce. And that is all. Okay, guys. So to find your scale factor, things to remember new point, or sorry, new side length, new point or side length, it doesn't really matter. Whoa, look at that. That was a mistake. I hit the eraser. There we go. Now, side length. This thing is going insane. Sorry, guys. Over old side length. That'll work every single time, no matter what the point of origin is, or what the point of center of dilation is. So that's to find your scale factor. You just need to do it with one side as well. It'll work. Which is one side. You don't need to do it multiple, but it doesn't matter what sides you pick as long as they're the same sides or corresponding sides. Okay, that's it. Hope this video helped. If you guys have any questions, please let me know. Greedy is out.